All right, you guys, last lecture for this week. So we want to get into chapter 2.3, which is going to be measures of central tendency. Again, by and large, you guys are going to find this stuff pretty easy. We're just talking about mean, median, and mode. We will talk a little bit about a weighted mean, as well as how this helps us look at our distributions and types of distributions we can see. All right, so measures of central tendency. This is going to be a value that represents a typical or central entry of a data set. Again, the most common measures that we're going to talk about are mean, median, and mode. Again, I'm sure all you guys, this is just repeat for you guys. As you learn me, you'll know I like to say this is Groundhog Day. I reference the movie Your 51st Dates. But again, your life's on repeat here. All of you can calculate an average. So let's talk about the mean or average. This is going to be the sum of all the data entries divided by the number of entries. We will use sigma notation. All right, so when you see that capital Greek E, looks like it's called sigma. And this notation, often you'll hear me call it sigma x. All right, but it's just telling us to add up all the data entries in the set. So again, just a symbol here that says, hey, add up all your entries. Okay, and we're going to use the Greek symbol mu. All right, mu here. It's kind of like this weird cursive M, looks like a U. We call it mu, different from the sound a cow makes. But mu here is going to be adding up all of our entries and dividing by the number of entries. That's what capital N stands for. So again, our mean, our population mean, is equal to adding up all of our entries and dividing by the number of entries. Our sample mean, you'll hear me call this X bar. Okay, so X bar, that's how I'll refer to it. And X bar, same thing, we're going to add up all of our entries and divide by the number of entries in our sample. Okay? All right, so let's look at an example. The prices in dollars for a sample of round-trip flights from Chicago, Illinois to Cancun, Mexico are listed below. What is the mean price of the flights? All right, well, what do we want to do, you guys? Well, first of all, we need to get sigma x, or add up all the entries. So we're going to sum the flight prices, and when we do this, when we add them up, we get $3,695. All right, and to get the sample mean, what we're going to do is we're going to take that sum, the 3,695, and divide it by the number of entries that we have. So how many entries do we have? 1, 2, 3, 4, 5, 6, and 7. So we divide by 7, and we get our mean price of the flights, which is about $527.90. All right, let's talk a little bit about the median. The median is the value that lies in the middle of the data when the data set is ordered. All right, I'm going to read it again just to be absurd here so it sticks in your head. The value that lies in the middle of the data when the data set is ordered. You guys, that is so important. The data has to be ordered. All right, it measures the center of an ordered data set by dividing it into two equal parts. If the data set has an odd number of entries, the median is always the middle data point or middle data entry. However, if there's an even number of entries, what do? The median is the mean of the two middle data entries. Okay, so again, if we have an even number of entries, what we're going to do is we're going to take the two middle numbers and average them. All right, so let's do the same for our Chicago to Cancun flight data. All right, so let's find the median. Well, what are we going to do first? The first thing we have to do is order our data. Does it matter if I order from smallest to largest or largest to smallest? No, it just matters that it's ordered, one of the two. So here I've ordered it from smallest $388 to largest of $872. All right. What are we going to do now? Well, there's 7 entries. All right, so what we're going to do is we're going to grab the middle number, or the 4th entry, and we find that the median price of the flights is $427. All right. Uh-oh. We found out that the flight priced at $432 is no longer available. So now we only have 6 possibilities. What is the median price of the remaining flights? All right, well, again, we're going to order our data, excluding the $432 flight option that's no longer available. So we order our 6 data entries. All right, what are we going to do now? Now there's 6 entries, an even number. So the median is the mean of the middle 2 entries. So we take 397, add it to 427, and divide by 2, and get 412. So once we lose that one flight option, our median changes to $412. Okay, lastly, let's talk about mode. All right, the mode is the data entry that occurs with the greatest frequency. A data set can have one mode, more than one mode, and it can also have no mode. All right, if no entry is repeated, then we have a data set without a mode. All right, if 2 entries occur with the same greatest frequency, each entry is a mode. We often call this data bimodal. All right, so let's take a look at our flight data again. Let's find the mode of the flight prices. All right, ordering the data, which sometimes helps us see repeating numbers. Do we see anything repeating? It looks like something does repeat. 397 occurs twice, whereas the other data entries occur only once. Therefore, the mode of the flight prices is $397. All right, let's do another example. At a political debate, a sample of audience members was asked to name the political party to which they belong. Their responses are shown in the table. What is the mode of the responses? Well, the mode of the responses is just going to be the response with the greatest frequency. How are most people aligned in this particular audience? Are they Democrat, Republican, other, or did they not respond? All right, we can see the mode is Republican because it's the response occurring with the greatest frequency. In this sample, there were more Republicans than people of any other single affiliation. All right, let's talk about comparing the mean, the median, and the mode. All 3 measures describe a typical entry of a data set. The advantage of using the mean would be the mean is a reliable measure because it takes into account every entry of a data set. Okay? The disadvantage of using the mean is it's greatly affected by outliers. All right? In other words, a data entry that's far removed from the other entries in the data set. For example, what if we were talking about housing prices in the US? Well, most houses are going to run between a reasonable amount of money. Let's just say maybe, I'm just throwing this out at the top of my head, maybe $80,000 to $500,000. That would grab the majority of houses in the United States. But there's people like Michael Jordan who have ginormous houses, Bill Gates. These are outliers. The fact that their homes cost more than $20 million are going to pull the mean up higher than where most of the data is. All right, let's find the mean, median, and mode of the sample ages of a class. Which measure of central tendency best describes a typical entry of this class? And this is something that you've got to be able to gauge. And guys, if you've worked with me yet in lab, you've heard me say this. Go with your gut. Your gut knows statistics, okay? So, what am I talking about? Let's figure out the mean. Well, we're going to add up all of our ages and divide by the number of students, which is 20, and we get 23.8 years. All right, so the mean average of the class is 23.8 years. For the median, we see that we have 20 students in the class, so we're going to average our 2 middle numbers, which is 21 and 22. So Here's our two middle entries. We're going to take 21 plus 22 and average them and get 21.5 years. And then we're going to look at the mode, and 20 years is the entry occurring with the greatest frequency because there's 6 20-year-olds in the class. So again, our mean is 23.8 years old, our median 21.5 years old, and our mode 20 years old. What do you think is the best single entry for our central tendency? Well, the mean takes every entry into account, but it's influenced by this outlier of 65. Notice all of our students are in their 20s, but we have this one 65-year-old, which is pulling the average mean, all right, the mean up higher. All right, the median also takes every entry into account and is not affected by the outlier. In this case, the mode exists, but it doesn't appear to represent a typical entry. All right, and so for this example, what we're wanting to think is that our median is going to best describe our data set. All right, so here's a graphical comparison of where is the mean. Let's look at this. All right, here leftmost, here's our mode. All right, our mode at 20, our median at 21.5, our mean at roughly 24, and then here's our outlier out here, way to the right, okay? All right, so what's our best descriptor of the central tendency? Clearly we can see that it's the median, okay? All right, let's talk about how you're going to go about calculating a weighted mean. All right, a weighted mean is the mean of a data set whose entries have varying weights. All right, so how do we go about calculating the weighted mean? All right, we're going to add up the product of each entry times its weight divided by the sum of the weights. All right, so this sigma W means sum of the weights. All right, so sigma W, sum of the weights, and then in our numerator here, what we're going to do is we're going to multiply each entry by the weight for that entry, and we're going to add up all of those. Okay, it's a little bit hard to explain with the notation. I think once we get to the example, you'll understand how this has already come up in your life. All right, where does it appear, guys? It appears with that grading policy on the syllabus. Everything carries a different weight. So how do you calculate your average in a course? All right, you're taking a class in which your grade is determined from 5 sources. 50% from your test average, 15% from your midterm, 20% from your final, 10% from your computer lab work, and 5% from your homework. All right, your scores, we got all the scores, the 86 for the test average, 96 for the midterm, 82 for the final exam, 98 for the computer lab, and 100 for the homework. What's going to be the weighted mean of your scores? All right, well, we go back to our problem and we know that the test mean, the test average, has a weight of 0.5. So we multiply our test average 86 times 0.5 to get 43. All right, the midterm carries a weight of 15%. So we take 96 times 0.15 to get 14.4. Similarly, the final exam weighs 20%, so we take 82 times 0.2 to get 16.4. The computer lab is 10%, so we take the 98 times 0.10. And then lastly, the homework is 5%, so we take 100 times 0.05. All right, since the weights sum to 1, we don't have to divide by anything, so we just sum up each of our entries times its respective weight, and we get a sum of 88.6. Is that enough for an A? Not quite. All right, the weighted mean for the course is an 88.6, so unfortunately you did not get an A. All right, let's talk about the mean of grouped data. So the mean of a frequency distribution. The mean of a frequency distribution is going to be approximated by the sum of each entry times the frequency, right? Each entry times the frequency divided by the sum of the frequencies, okay? This x is going to be the midpoint of the class. Okay, so again, we're going to use the midpoint of the class and the frequency of the class. We're going to multiply the midpoint times the frequency, add them all up, and divide by the sum of the frequencies. Okay? So I'm just going to review a little bit the words and the symbols here. So with finding the mean. So one here, finding the midpoint of each class. How do we find the midpoint? Remember, we add the lower limit and the upper limit of the classes and divide by 2. We want to find the sum of the products of the midpoints and the frequencies. We want to find the sum of the frequencies. And we want to find the mean of the frequency distribution, which essentially here in number 4 is just dividing our answers to number 2 and 3. All right, so let's use the frequency distribution to approximate the mean number of minutes that a sample of internet subscribers spent online during their most recent session. Okay, so we have our frequency distribution. First, what we want to do is calculate the midpoint. Right? So I create this column, and I'm going to calculate the midpoint by adding, for the first one here, I'll add 18 and 7, which is 25, and divide it by 2 to get 12.5. I add, again, the upper limit 30 to the lower limit 19 in my second class, divide that by 2, so divide 49 by 2, and I get 24.5. And I continue doing this for each class. Okay? Now, what I want to do is I want to create another column where I am multiplying the midpoint times the frequency. So here I take 12.5, multiply it by 6 to get 75. I take 24.5, multiply it by the frequency of 10 to get 245. All right, and so forth. All right, now I need to know, well, how many frequencies do I have? I add up my frequencies to get n is equal to 50, and I add up everything I calculated in this last column, so each midpoint times the frequency. I add them all up, and I get 2,089. To get the mean of the frequency distribution, all I do is I take the mean of the midpoint times the frequency, the 2,089, divide it by the sum of the frequencies, and I get approximately 41.8 minutes. And let me go back to this one more real quickly here. I know that this is a lot of words. It sounds crazy when you're hearing it. Just try to get down the idea of the process, and just know that once you go through a couple of these, it is so much easier, especially when we do it on Excel. All right, lastly, we want to talk about the shape of distributions. So let's first begin with the easiest, a good old symmetric distribution. All right, a vertical line can be drawn through the middle of a graph of the distribution, and the resulting halves are approximately mirror images. In other words, the left and right are roughly symmetric. We can also think of it in terms of central tendency, and in terms of central tendency, we would say our mean is equal to our median, which is equal to our mode. Okay, all measures are the same. We can have a uniform distribution. Sometimes you'll hear this called rectangular, but you will always hear me refer to it as uniform. All right, this means all entries or classes in the distribution have equal or approximately equal frequencies. Okay, yes, it is symmetric. Okay, the mean and the median are equal, but there is no mode. Okay. All right, now let's get into our skewed distributions. What the skewed left mean, all right? And sometimes you will hear this referred to as negatively skewed. This is the key, guys. The tail, all right, what's a tail? Here's the tail, the thinning out part. The tail of the graph elongates more to the left. So the tail is on the left, which makes it left skewed. All right, another way to think about it is the mean is to the left of the median. Why? Because this tail, this unusual data, is skewing the mean to the left. So you can either think of it as the tail is to the left or the mean is to the left, and that means skewed left. All right, conversely, we can have skewed right. What does skewed right mean? Skewed right means the tail is to the right. So here we have our unusual or thinning out data to the right. And in words of the central tendency, this is telling us that the mean is to the right of the median. Why? Because this tail data is pulling the mean to the right.